Hello, software engineers. A lot of twos today. Thank you for joining me on day 21 of CSC 222. For a low monthly fee, I will comment on all of your worst tweets as if they are brilliant. If you tweet eating soap cures COVID, I'll leave a comment saying this with an arrow emoji. I would pay a lot for that service. All right. Onward then. Let's start off today by talking about exam number 2. As a class, you did well. Please make your own determination. One thing I should point out, and I know you see this in the syllabus also, is exams are part of the course, but they're not the majority of the points in this class. Even if you don't do spectacularly well on the exams, you could still do very well in the class. I would encourage you to do well on the exams. I think that's helpful also. Let's take a look at a couple of the items on the exam. I don't want the exam to just be an assessment. Of course, it is an assessment, but I'd like it to be a learning experience also. So let's review a couple things. One of the disadvantages of doing exams online is not being able to hand back paper copies and say, look at question 3 or whatever it might be. I'm going to show you some of the questions that seem to be a little more problematic. And then I certainly want to talk about all the short answer types of questions. If you have a specific question, you can feel free to ask, or if you'd like to just shoot me a mail message and talk to me out of class, that would be just fine also. There weren't a whole lot of true, false, or multiple choice questions that were problematic for the majority of folks. As a matter of fact, there are only 4 that seem to trip people up in some way. I think everybody had, I don't think I randomized things, so question 7 should have been the same for everybody, true, false. During architectural design, specific module algorithms are created. If you recall, and this is something to think about for the short answer question on the design phase also, how is it carried out? 2 basic elements of design: architectural design, which is a high-level design. In architectural design, we identify what modules or functions or objects are needed and their interfaces, their connections, but not algorithms. So that answer is false. In detailed design, and that subphase or milestone of the design, then specific data structures are chosen, specific algorithms are created. Yes, that does happen in design, but not in architectural design, in detailed design. Question 14, professional coding practice attempts to ensure the user interface is meaningful and consistent to the end user. Now, we do want the UI to be meaningful and consistent. We saw that as a design consideration, but that's not part of professional coding practice. That's false. Professional coding practice are issues like meaningful identifiers, the use of white space, the use of indentation, following your guidelines that your organization sets up for readable code. Professional coding practice is all about creating beautiful, that is, readable code. And that has nothing to do with the UI. Code is internal for us, software engineers. Users don't see our code at all. 14, false. Testing is, some of you recall that I said this 5 times. Now, I don't know why it trips people up. Testing is used to improve the quality of a product. That's false. You cannot improve the quality of a product by testing it. If you got that question wrong, I tested it. It didn't improve it at all. Now, people want to say, oh, but then you'll figure out what's wrong. And well, that's something different. That's debugging. That's not testing. The purpose of testing is to find errors. A good test uncovers an error. Testing cannot improve the quality of the product. The quality of the product is what it is. Testing will uncover that. And only one of the multiple choice questions seemed to trip up some people. Is it because I didn't define what software engineering is? Surely at least 19 out of the 20 previous times we met, I said software engineering is management. Did it trip you up that it was self? Management of self and process during development. Yeah, what are you managing? My own skills, my own abilities, my own time, and everything else during the development process. You know that software engineering is not an algorithm, right? It's only partly algorithmic, partly heuristic, part art, part science, part creativity. So it wasn't the second one there. Let's take a look at the short answer questions. You'll have to reference those. By the way, I have Blackboard set up such that you should be able to see it after everybody has taken the exam. So if you went back immediately and said, what are the answers? Well, it's going to wait until everybody has completed the exam to do that. You should be able to see what you said. All right, and my comments. And my comments are really designed to make you wait for today. Number one, what's the purpose of the design phase and how is it carried out? I sure hope that that didn't surprise anybody. On exam one, this is one of the questions in the study guide. And in exam one, I asked you this exact question about requirements and specifications. The two major phases in this unit just completed, design and instantiation. So guess what? Yeah, I asked you those same questions. What's the purpose of the design phase? Two things. Number one, design determines how the product solves the problem. You really needed to use that word how. Design determines how the product solves the problem. If you said it's the blueprint for coding, kind of the same thing, but I really wanted that word how there. Second aspect, design plans algorithms and data structures. Design begins, as you said, it begins the implementation of the idea. It's kind of the same thing. Man, I really wanted to see algorithms and data structures. So that's the purpose. How's it carried out? Two major subphases. Number one, architectural design that determines the modules and their relationships. That was the cohesion and coupling concepts. Determine the number, the type, the features, and the relationships of the modules. The second part of the how is detailed design. Detailed design determines, guess what? The details for each of the modules. What do I mean by that? Using pseudocode, we also called it PDL, Program Description Language. Create the algorithms, create the instructions. And yeah, these instructions are procedural. They're not declarative. This is not a what thing like specs. This is a how thing. Now, beyond that, to get full credit, there were about half a dozen or more other specific things we said about purpose and how. For example, you supplement informal English with semi-formal techniques, how? Diagrams. Consider coupling and cohesion. That's another part of the how. Software engineers, unlike coders, think ahead. They consider what might go wrong and how to deal with slips and mistakes. Software engineers, how? We create robust code. That's a goodness feature that we'll hit again later. If you said design is the heart of software engineering, or it's the most difficult of the processes, phases, yes, absolutely. So 2 things specifically for purpose and 2 things specifically for how, and then one other important point that we mentioned, that was full credit. Otherwise, you got partial credit based upon that. Short answer 2, do the same thing for the instantiation phase. What's its purpose? How is it carried out? Purpose. If you said instantiation is meant to instantiate, yeah. Okay, no extra credit, just because that's my favorite word. What does that mean? Change the design into a concrete product, or change the design to instantiate, change it into actual code, change it into an actual product, right? How? Well, design is the blueprint that you follow to make the product. Some other things about the how you should have said. Professional coding practice. Remember, instantiation is all about creating code. You didn't have to list every aspect of it. It would have been fine to just say following professional coding practice to ensure that we have beautiful code. And the beautiful here is readable, understandable to me a month later, and to any other person, any other software engineer who looks at this in the future. How? Well, this is again where we talked about breaking something complex down into more manageable or simpler units that we call modules in general. You might call them methods or objects. Coding a module is done by teams, typically, considering the aspects of coupling and cohesion. Here's where we talked about user interface design, even though it's instantiation. So if you did that here, that was good. And then, of course, a big aspect I really wanted you to talk about in instantiation was code verification, testing to verify the goodness of the code. Testing has to be planned also. And there were some other things, but those were about 8 or so major points. Give me 5 of those, that's full credit. Otherwise, partial credit. Third question. List and explain the major characteristics of good design. These are what I identified as the transcendentals, the philosophical ideas. Truth, beauty, goodness, community. Community is kind of a made-up one. The Greeks didn't talk about that. They talked about truth, beauty, and goodness. But I talk about community. Now, make sure you know what each of those relate to. Truth is the design accurate. How do I know the design is truthful? If it meets the specifications. Design is truthful if it meets the specifications. Beauty. Is the design understandable? Are the design documents understandable? Is the design readable? Would an ordinary software engineer, you and me, be able to pick up this design document, read it for comprehension, understand what's there? And yeah, pleasing is part of it. I suppose you could have ugly looking diagrams and more pleasing looking diagrams. But the key idea with beauty is readable, understandable. The third aspect, goodness. Goodness is not referring to the accuracy of the design. Does it actually add numbers? Nope, that's truth. Goodness is Does the design go beyond the mere accuracy? I gave you two different concepts of this. Number one, is the design robust? Good design is robust. It thinks ahead and considers what might go wrong. Oh man, might the user type in a letter instead of a digit? If so, I got a design for that. Is it robust? Can it deal with the unexpected? How does it handle user mistakes? That's good. If you don't do that, then your code doesn't either, and your code just bends out to the operating system. That's not good. The other characteristic of good design that I mentioned is efficiency. If the specs say sort and the design does a bubble sort, that's good. But if we're doing a bubble sort, as we saw on 1 million records, that's going to take that's going to take seconds to do. Nobody's going to hang around for that, right? Yeah. So what do I mean by good? Is the design robust? Is the design efficient? Kudos if you added community, and the community aspect is a good user experience. Very good. The extra credit that was shoved in between the true, false, and multiple choice sections there explain one's aspect of professionalism cited by your instructor, that's me. Some folks just made something up. Could have worked, but I wanted one of the 7 that we have cited so far: being dedicated, on time, cool and calm. We had another word too. Honest, civil, team player, dependable. Took those out of order, but you get the idea. We'll introduce a new one today. All right. And so tell me and show me with software engineering example, how would being civil or honest or on time, how would that help? If you did well on exam 2, thank you. Thanks for putting forth the effort. If you didn't do as well as you like or hope, well, we've done 2 of these now, and there will be one more. So hopefully you're sort of picking up on the kinds of things you need to deal with there. I should mention at this point that there is one more exam in CSC 222, and that will happen during the final exam week. Yet, or I should say, but it's not a comprehensive final exam. The 3rd exam in this course is a unit exam. So it's just going to cover the material from this last unit that we're going to begin today. Oh, I hope that helps. All right. Do you have any questions in general? I can think about those. Or if you'd rather just send me a message, I'd be happy to respond. All righty. Some housekeeping things, just in case you didn't notice these on Blackboard, assignment 17.5. Folks, I apologize for the 0.5s here. It's just a little easier for me to keep Blackboard satisfied if I add something in between like this. This team project where you're going to decide which of the various projects your team would like to work on. I do know that you don't know everything about those projects, but you will, because in this last unit, I'm going to ask you as a team to carry those out. If you didn't quite get this buttoned up at this point in time, please get that taken care of today so I can look at them and then be ready to know what folks are doing. We're going to go full bore into the team projects beginning next week. CNCS 9, we'll begin talking about that, the 8th commandment today. That'll be due a week from today. Except for there's a little problem. There's a little problem. Somehow I missed this when I originally looked at Irvine's schedule. For some reason, next Wednesday, you have as a holiday. You're celebrating Veterans Day. Now, first of all, good for you for celebrating Veterans Day. Mequon doesn't take Veterans Day off, but a couple of weird things. First of all, Veterans Day is a Monday holiday type of thing. And the actual date of the original Veterans Day, which was originally Armistice Day, is November 11th. So I'm not sure why the 9th. And I mean, I missed it the first time I even looked at it. And for some reason, I was looking at the Irvine academic calendar today, and it's a November 9th, Veterans Day, observed, no classes. Weird. All right. So what's that mean? It absolutely means we will not have a class that day, but you could probably do both of these things. I'll push them ahead to the next day, but I want them taken care of by a week from now so we can move on beyond that. All right. I'll remind you on Monday. Has that always been the case? You guys always take Veterans Day off, or is this something new? Anybody know? Well, you might not be able to unmute yourself. It's okay. Are you just happy you get the day off? Oh, thank you for telling me. Okay, good. Well, again, good for you. If you are a vet, do I have any veterans in this class? If you are a veteran, or if you know a veteran, thanks for your service. If you know a veteran, tell them, thanks for your service. I know they'd appreciate it. All right, so CNCS 9, although Blackboard says next Wednesday, we'll push it ahead to Thursday. Same with assignment 17, which we'll talk about at the end of class today. All right, good. So now you know. Speaking of now you know, let's talk about my 8th aspect of professionalism, being respectful. I need you to attend a meeting for your boss while he's on vacation. I plan to bully you into making decisions that are bad for your department. It's almost as if you have no respect for me. Yeah, almost. Unsurprisingly, I'm going to connect this to one of the commandments. The 8th commandment, remember, if you're not a Lutheran or didn't grow up Lutheran, you may number the commandments a little differently. Here's how Lutherans number the commandments. You shall not give false testimony against your neighbor. I am so old that the language in the catechism when I was a little boy said, you shall not bear false witness against your neighbor. I don't know, that sounds cool. You shall not give false testimony against your neighbor. It's easy to see what not to do. Ted is being rude and unhelpful. Can you ask his boss to remove him from the project? Ding. I'll forward this to Ted. That should help. I wonder how people solve problems before email. Actually, throw this one up for another reason. It may not have happened to you yet, but no doubt at some point in time this will happen to you. If not as a student, then certainly as an employee. Always carefully word email messages. They are really easy to forward to people. Yeah, okay. And obviously, if it's false, we don't want to do that. But, well, let me show you what Luther said as the meaning of the 8th commandment. We should fear and love God so we do not tell lies about our neighbor, betray, slander, or hurt his reputation, but defend him, speak well of him, and explain everything in the kindest possible way. I cannot tell you how many times I have said something in an email sent to like a boss who has just turned around and sent that to other people, directly talked about in that mail message. This happens all the time. I did learn rather quickly to phrase things in the best possible way. And then beyond that, if you really want to say something, well, it's okay. I just go find the person. Yeah, talk to them one-on-one and hope they don't have their voice recorder going. CNCS 9 is going to ask you to relate this to the concept of being respectful. I think you can do that. Onward. Unit 3, CSC 222 Software Engineering has 3 academic units. We've done 1 and 2. We're now going to begin Unit 3 that I have entitled Interaction. We'll review that. Interaction. Another way of thinking about interaction is this is the power of the product that we make. And my rhetorical question, what good is an app if it isn't or can't be used to solve problems? What good is an app if it can't be used to solve problems? That question is definitely rhetorical because you know the answer. No good at all. Our ultimate goal is to create an acceptable product. Somebody's going to use it. The user is going to employ it to solve problems. So we're going to focus on the concept of interaction in this unit. Our internal processes are so inefficient that we can't get products to market before they are obsolete. I'll create a multidisciplinary task force to look into it. You want to use an inefficient system to fix an inefficient system? It's called fighting fire with fire. Some supervisors love to put together a little task force to solve. Why don't you just solve the dang problem? Good idea. If you were suffering as a computer science student in Mequon, Wisconsin, you'd immediately know the answer to this because all 5 of the faculty members, we all say the same thing. The concise definition of computer science, and you've heard it from me before too, so maybe you remember. The concise definition of computer science is problem solving. That's it in a nutshell. Oh, yeah. And that's why software engineering is professional problem solving. Right. What's the purpose of a computer system? Faster. Answer: to solve problems. We are totally focused on this idea. And this happens during interaction. When you create an app, it's not solving any problems. Not until we deploy it, hand it over to the user, who is now going to run it and solve problems. I've done this before. It seems legitimate to do it now. Any creative activity, and software engineering is a creative activity. Any creative activity has 3 aspects: idea, the mental model. You know what we really want to create here is and you envision it in your mind. Another aspect of the creative activity is implementation. Darn. Now I got to get this wonderful idea out of my mind, get it down into some concrete thing. And then interaction, where the user is going to work with our tool and be impressed. Those are the 3 units of CSC 222. I think I have it here next. Oh, we're not going to do that. We will see another article by Fred Brooks, but we're not going to take a look at this one right now. Anybody ever hear of Bill Gates? He's an old guy, probably not very relevant anymore. At one time, about 10 years or so ago, he was one of the richest people on planet Earth. For a period of about 10 years from '05 to 15, he was either 1, 2, or 3 all the time. Do you know who that is? The founder, past president, past CEO of Microsoft Corporation. I think it's fair to say that personal computers have become the most empowering tool we've ever created. Can I add something? We've created so far. They're tools of communication, they're tools of creativity, and they can be shaped by their user. Interaction. Interaction's important. Tools. Shaped by their user. Some of you have heard of this person. What a computer is to me is it the most remarkable tool that we've ever come up with. It's the equivalent of a bicycle for our minds. What does Steve Jobs mean by bicycle for our mind? Well, you know what a bicycle, a mechanical tool provides a mechanical advantage. The levers and wheels in a bicycle mean it can multiply your muscle power. You can go farther and faster on a bicycle than you can running. Why? Because it gives you a mechanical advantage. It's called physics. Levers, gears, wheels. Yep. What Steve Jobs meant as a bicycle for our mind is computers don't give us a mechanical advantage. They give us an informational advantage. We can multiply informational tasks. We can expand our intellect using these things. This quote and the previous one are just meant to illustrate interaction. Absolutely. Anybody know the answer to this? How many college degrees did Bill Gates earn in his lifetime? He did begin attending some little school back east. I think it was called Harvard or something like that, but he dropped out. Now, he amassed a number of honorary degrees after he made billions of dollars, but no, didn't have a degree. How about Steve Jobs? Nope, not that either. Fortunately, when he started Apple, there were 2 other people. Do you know originally there were 3 people that formed Apple? The third person, no, I can't even remember the name. He only lasted a few weeks. The other person, though, was Steve Wozniak, who was a degreed computer scientist and worked for Hewlett-Packard Corporation, the company I was at, before he took up with this hippie in the woods and did that thing. There are several terms that I have used a couple different times, and I just want to make sure that you understand these terms, okay? We've used them. Let me pause here and be sure that you have a definition in your mind of project, process, and product. Let me look ahead. I don't think I've defined them. I think I actually have to do that right now. Thank you. What's a project? A project is defined as a planned and managed undertaking. Project. You have team projects. You've done an individual project, a planned and managed undertaking. And as we've seen, that relates a lot to idea. Managing? You bet. Another PRO word in software engineering is process, like the SDLC. Process is defined as the steps or actions and guidelines followed. Steps, actions, guidelines followed. That's what the software development lifecycle is all about. Do this, do that. Here's how, here's when, here's why. When it comes to software engineering, this really relates to the implementation. And the final PRO word for our edification today is product. Product is defined as the created, useful tool. The created, useful tool. And that relates to interaction. Oh, maybe I should. How do I know if my project was successful? Well, two ways, and they relate to these. Number one, a successful project produces an acceptable product. How do I know my project was successful? Number one, I produced an acceptable product. And number two, I followed a defined process, aka professional project management. I followed a defined process, that is professional project management. All right. We've covered 4 of the 6 phases of the software development life cycle. Yeah, let me do these and then we'll stand up. We have talked about the requirements phase and the specifications phase. We did that in Unit 1. Both of those relate to the idea. In the unit just completed, we discussed design and instantiation. Both of those relate to implementation, getting the idea out of our minds and paper into a concrete form. In this unit, we'll look at these 2 phases of the software development lifecycle: deployment and maintenance. These are some of the key ideas dealing with interaction. Now, out of necessity, we're going to go back to some previous phases and pull things in, talk again about user experience, etc., just because it makes sense here also now that we've seen it. Good. All right, you know what? I want to preview deployment and maintenance, but the atomic watch on my wrist says it is time for us to stand up. Will you play along with me? Thank you. All right, so a minute, synchronize your watches. I'm going to stand up. I'll disappear then. I didn't disappear. Stand up, walk around, get a drink of water, come back in 1 minute. We'll do it again. Close. All righty. We'll look at each of these phases, deployment and maintenance, in depth, but let me overview them today. Deployment. Classic dictionary definition: the act of moving something into a strategic position or a position of readiness. And yes, in honor of upcoming Veterans Day, if you served, the word deployment means something very different to you. It does mean this, but it means you're going somewhere. The act of moving something into a strategic position or position of readiness. What's that have to do with software engineering? Well, you've already done this. You did this when you took your executable file, changed the extension to .pgm to full Blackboard, and uploaded it to Blackboard. You were deploying it. Now, there's a number of things that need to be done in software deployment. But for us, we just wanted to get that ready into a what? Position of readiness. You upload it to Blackboard, it's ready for me to download and run. Software deployment. Software deployment includes all activities that ensure a software system is available for use. And I think I was always surprised at the number of things that go into this. In the bad old days, people had to manufacture optical discs, right? A DVD or a CD that had the code on it that you would send to somebody. And you're saying, well, all you have to do today is just put it on the server. Oh, really? Just put it on the server and people will just download it. Nope. Lots of things happen. Software deployment includes all activities that ensure a software system is available for use. I want to share this with you. I have briefly mentioned DevOps before, and a little visualization of what DevOps is all about. Okay. All right. I got to wait for it to come up before I switch over there. Let's see if it's come up somewhere. Aha, here it is. Good. Yes. Are you going or not?
Right from the start, software development comprised two different departments. The development team that develops the plan, designs, and builds the system from scratch, and the operation team for testing and implementation of whatever is developed. The operations team gave the development team feedback on any bugs that needed fixing and any rework required. Invariably, the development team would be idle awaiting feedback from the operations team. This undoubtedly extended timelines and delayed the entire software development cycle. There would be instances where the development team moves on to the next project, while the operations team continues to provide feedback for the previous code. This meant weeks or even months for the project to be closed and final code to be developed. Now, what if the two departments came together and worked in collaboration with each other? What if the wall of confusion was broken? And this is called the DevOps approach. The DevOps symbol resembles an infinity sign, suggesting that it is a continuous process of improving efficiency and constant activity. The DevOps approach makes companies adapt faster to updates and development changes. The teams can now deliver quickly, and the deployments are more consistent and smooth. Though there may be communication challenges, DevOps manages a streamlined flow between the teams and makes the software development process successful. The DevOps culture is implemented in several phases with the help of several tools. Let's have a look at these phases. The first phase is the planning phase, where the development team puts down a plan, keeping in mind the application objectives that are to be delivered to the customer. Once the plan is made, the coding begins. The development team works on the same code, and different versions of the code are stored into a repository with the help of tools like Git and merged when required. This process is called version control. The code is then made executable with tools like Maven and Gradle in the build stage. After the code is successfully built, it is then tested for any bugs or errors. The most popular tool for automation testing is Selenium. Once the code has passed several manual and automated tests, we can say that it is ready for deployment and is sent to the operations team. The operations team now deploys the code to the working environment. The most prominent tools used to automate these phases are Ansible, Docker, and Kubernetes. After the deployment, the product is continuously monitored, and Nagios is one of the top tools used to automate this phase. The feedback received after this phase is sent back to the planning phase, and this is what forms the core of the DevOps lifecycle.
Oh, all right. I call that? Okay. Hold on just a minute. Oh, come on. Okay. Can you hear me still? Somebody put in chat if you can hear me. Don't make me ask it. Okay, thank you. But we still, do you still right now hear the feedback? All right. Let me hold on a second. I don't want to kill everything. Oh. Yeah, I've gone through several processes of muting, unmuting, etc. And I'm not sure where that is. Okay, hang on just a second. Wow, it was in the share yeah. Zoom does all kinds of weird things. Yeah. Okay. Yeah, thank you. Yeah. I just kicked Zoom in the head and stopped the share and went back here. So sorry about that. What I wanted to point out in this world of DevOps, which is just another variance like Scrum, a way to do the software development lifecycle, is you saw that separation between the first four phases and then this deployment phase. Just as before we saw in quality assurance, there might be a separate QA group to do things. It's pretty common historically that once the product is built, then another group needs to figure out how to deploy it. But more modern approaches, both for quality assurance and for deployment, would say that should all be handled by the same team for greater accountability. All right, the second phase we'll discuss in this unit is the maintenance phase. Maintenance phase. Dictionary definition of maintenance: to keep in an appropriate condition, operation, or force. Keep unimpaired. Keep in existence. Maintenance: keep in an appropriate condition. If it works well now and looks good now, I need to maintain it so it will continue to work well and continue to look well. Now, for an automobile, that would mean doing routine maintenance, like changing your oil and waxing your car. Anybody still use wax? I don't think anybody does that anymore. What does that mean for a computer system, and what does it mean for software? Software maintenance. Software maintenance is defined as any change to the product after deployment. Any change to the product after deployment. So, for example, what if we found an error? What if the user found an error? Well, now we might be contractually bound to change it, fix it, correct it. That's a change to the product after deployment. That's our standard definition of software maintenance. Do you know they renamed a street Chuck Norris? I think they did that in La Brea. Anybody see that? They took some street somewhere and they named it Chuck Norris. Then the town council had to change the name back. No one crosses Chuck Norris. No one crosses Chuck Norris. Maybe you don't understand the words. Speaking of not understanding the words, Zeb asked Zeke, "Hey, Zeke, do you know what apocalypse means?" Zeke thought a moment and said, "No, I don't." Zeb shrugged and said, "Well, I guess it isn't the end of the world." Get it? Apocalypse, not the... You guys got to do some maintenance there. This is hilarious, but I think we need a little more background. Guy has a little poem all about the 7 deadly sins of software deployment. I think you'd be able to understand 1.5 of them, but okay. I thought it was funny, but let's stop doing things I think is funny. Do I want to share? I don't want to share all the, oh, no, I can't do it. I killed everything. Let's take a look at 2 of these just briefly. New share. This article, important job skills for software engineers. What do you think they're going to say? You only have 2 moves. How to find a job. This is a very interesting initial comment. This is highly debated. Also known as software developers, software engineers. Boy, there are some folks that see a huge distinction between somebody with the title software developer and software engineer. I'm not making that distinction. I'm not doing that this class, but you should know some people do. I mean, after all, we said what's software engineering all about? The management of the entire software development process. Not all have a college degree. Many of them acquire a degree in computer science or machine learning. Yeah. What skills do these folks think you need? What do they do? Okay, I think we know what they do. Multitasking. As a software engineer, will be required to manage multiple projects in a deadline-driven environment. Whether you work remotely or freelance or full-time employee in an office, you'll need to manage multiple projects at once. This is also highly debated. At some point in Unit 2, we talked about Kanban, this other philosophy the Kanban philosophy that's working its way into software engineering says you want to focus on one task. Remember the board with sticky notes and you pick one of them and you do it? There's some good psychology that suggests single tasking in parallel, single tasking in serial is more efficient than multitasking in parallel. But regardless, the odds of you being able to just focus on one thing exclusively, either throughout the day as a software engineer or throughout even an hour, is low. Think about being a student. You have to juggle many things. You've got more than just this class. The only time that you could possibly only focus on this class is during class time. I guess I won't ask you if that's all you do during this class time. But this evening, likely you'll have other assignments and other classes, and somehow you have to juggle those. But the key word that I want to bring up, as you might suspect, is manage. Able to prioritize, triage, manage all the various milestones of all the various projects on their plate at a given time. Software engineers need to be able to thrive in an environment where deadlines occur regularly. Can you organize? Can you prioritize? Can you meet deadlines? Can you manage expectations? By the way, other than we use multitasking in the context of computer organization and architecture, that's not what we're talking about here. This doesn't seem like hardcore computer science, does it? No, this seems more like management and professional problem solving. What about the second necessary skill? Teamwork. Yeah. Building software systems is generally a solitary endeavor, but a software engineer will still be able to communicate with other people. What? I don't know where these people live. I am not familiar with too many organizations, none that I ever worked with, none that I currently work for, nor any of my students will share with me, oh yeah, all I work on, I'm the only person on the project, that's all I'm working on. No. You are going to work as a team. This part's true. This leading sentence, I have no idea. You may be required to work with people whose ideas and philosophies you don't agree with. You probably already have done that. That might describe your team right now. Other time, misunderstandings arise, can threaten you and your team's deadline. Collaboration, compromise, active listening, yes. And oh boy, communication skills. So do you find it interesting? Oh, the fourth one, finally, they're going to talk about something technical that you might get with a computer science degree, computer coding languages. Many software engineers are fluent in one or two coding languages. Many? All. Can you be a software engineer and not know how to code? No. Get over that. Hey, there are different types of, at least I was a little worried. I wasn't going to even use this article if they had mentioned C#. Okay. Python's the big sexy one right now, right? If you feel badly because we're not programming in Python because it's big and sexy, don't worry about it. Big and sexy happens every 5 years. And then we're on to something else. More skills. Okay, good. One other one, let's take a look at. What somebody else thinks you should know. The top 12 things every software engineer should know. The first version of this article had the top 10 things, but that wasn't enough. So we had to add a couple. Whenever I see this, I think of Young Frankenstein and, the Abby normal brain. If that means nothing to you, it's okay. Notice the very first thing this author says, fundamentals of emotional intelligence. What is that? It used to be called soft skills, and it's what I call professionalism. Soft skills, emotional intelligence, soft professionalism. That's what we're talking about. Yeah, exactly. Oh, darn. Why did I say that? Yes. Algorithms, well, we're certainly learning a lot about that. As a sophomore level class, I won't talk about big O notation. I'm sure it's something that you will experience in the future. Yeah, Frankenstein, good. In some other classes. Big O notation deals with efficiency. How do I know the goodness of my algorithm? Which sort is better? Which is more efficient? We answer that using some theory called Big O. Basics of project management. For us, what they're saying is project management, that's just the software development lifecycle. That's just software engineering writ large. Effort estimation. Oh, yes. Mainstream development paradigms. I don't know. I mean, C# is OO. Do you really need to know procedural programming languages? Do you really need to know COBOL and Fortran? I don't know. Software security? Oh, yeah. We've talked a little bit about it, and we will cover this in the third unit, this unit of software engineering. Do you have to know development tools? Do you have to know some things about Visual Studio? I think so. This is an interesting comment. Don't trust code without adequate test. I don't trust code until it's passed unit testing, integration, system, checks performance memory, static code analysis, measure code coverage, load and stress peer review. Static code analysis and peer review are human beings looking at the code, trying to answer the question, does it really work? We'll ignore that one. The root cause of the last defect. You see a lot of questions and the list is still not complete. The most important point is to find the cause of the error such that that cause isn't made again. Understand your customer. That's our very first step, right? Understand the problem, requirements. Why is there a problem? You can't do that unless you talk to the client. Infrastructure we'll ignore. Know what you don't know. I'd say that's the most difficult point on this list. To get a better software engineer. To get a better software engineer, lifelong learning will be necessary, and this should be planned in some way. To get a better software engineer. Okay. Lifelong learning. Absolutely. You thought it was over. When you graduate, school's not over. Sorry. This was an interesting article, but I want to make sure I got time for what I want to talk about and not what I want you to know. You don't have to remember the name. Oh, strike that from the record, Your Honor. Because the question on the exam might say something like, Peter Coffey believes that software engineers, blah, blah. So, yeah, okay. Peter Coffey, wow, that's an old guy. I think he's older than me. So now you know two really old people, me and Peter Coffey. Peter Coffey's been a rock star for a number of years in the world of software engineering. He wrote a very classic and influential article years ago that said software engineers need to be a breed apart, where he was making a distinction. Well, he actually made three distinctions between scientists, engineers, and artists. But I want to focus on the distinction he made between artist, which is what we would call a programmer, and software engineer. He said a good programmer can write programs that run the first time. A good programmer can write programs that run correctly the first time. But a software engineer can tell you how their programs will fail and with what effects, if given unexpected data or if used in an abnormal way. So a good coder, a good programmer can take the specs, write, and it is truthful, but it's not necessarily good, because a software engineer will look at that and say, here's how the product might fail. I understand slips. I understand mistakes. What if the user types an A instead of a 5? What's going to happen here? Software engineers can look ahead. They can tell you how the program will fail and under what circumstances. That's us. That's you. Good for you. Let's look at assignment 17. Assignment 17 is excuse me, another incarnation. You're wondering, is this the last one? I don't know. This is sprint 5 of the add numbers. I encouraged you to take apart your user interface and redo it. I did it to mine. I don't know if I'm happy with it. I was actually happy with my previous stuff, but I said, take it apart and redo it. Now, if you really think your previous UI was good and I didn't say anything about it, then that's okay. But you're a software engineer. You can think about these things. What will make sense to the user? All right. Now, there's a couple of additional things you need to do. Let's switch. Oh, I hope I didn't blow that away. Let's switch over to my Windows partition here. And let me run for you. Here is my sprint 5, my assignment 17. All right. Now, notice, first of all, the focus, can you see it? It's right there. It's in the input box. As soon as I start, I don't have to click in there. As soon as I start typing like 0.2, it's right there. The enter or the return key does the add. I'm not going to click on add. I'm going to press return. And notice a couple things. Not only does it update these statistics, if you will, but now my focus is back in the input box. The input box is wiped clear, and now I can type another value, 0.21, enter. 0.19. I can click add, that works. And so it goes. All the previous things, like what happens if I type in an A? A. Invalid input, enter valid numbers only. Oh, sorry, I meant to type in point A, 0.23. And so it goes. No, don't keep saying there's an error if there's not an error. Clear that. There's not an error. Now, some things that we saw before, okay? The total weight of the bundle is displayed. Current total weight of the bundle, 0.83 pounds. The current number of shims in the bundles, that's displayed. Now there's some other things. You don't have to have these. As a matter of fact, I didn't even say use the average of standard dev. I just said minimum, maximum. These don't have to be here on the form. They could just be when you print it out. File, print. But notice these two things do need to be on your form. What's my bundle limit? 5 pounds. And then notice this here, 4.17 pounds until bundle full. How did it know? Well, 5 minus 0.83 is 4.17. So look at the requirements and specifications. Make sure that, first of all, your current implementation, sprint 4, might have to make changes to it. Make sure it satisfies all the requirements. Do you have a menu with help? Do you have, if you just want one menu item where you have help, and you don't have to have quit, you don't have to have change bundle limit, where you have save and print. Yeah, you got to have that somewhere. Now, be sure, give it a good name, make sure that it does everything it should have before, and then add the new stuff to it. Does clear work? Does undo work? Test that all out, just like you did for assignment 16.5, where you were testing that little app with your test plan. Yeah, test it out. And then add these new features, and you're ready to roll. As before, I would expect to see two things. I would expect to see your code, your .cs file, that can be uploaded directly, and your executable. So you're going to need to change the extension of your executable to .pgm to upload to Blackboard. Blackboard says it's due a week from today, Wednesday, November 9th, but because it is a holiday, we'll do it the next day, Thursday, the 10th. Do you have any questions about assignment 17?
Would you like us to make the UI similar to what you have presented here?
You know that you don't have a great question. It doesn't have to be similar to this, but give it some thought and what would make sense to the user. I honestly don't like all this stuff on it. I shouldn't have put that on there. The general guideline of separate the input from the output via the function. Yeah. It doesn't have to match this, but I would encourage you to rethink it. If you want to make a change, I think that would be good. Great question. Any other questions on assignment 17? All righty. You can just note this. Oh, question, sure. Sorry. Yes.
Do you want us to have the change bundle limit menu item?
No, good. I don't think I said that. I did that because just to experiment with it. Thanks. I'm sorry, Ryan, I didn't see that. You don't have to have that change, but the change bundle feature would just say rather than 5 pounds, my bundle can now be 7 pounds or 3 pounds. You don't need to do that. Good question. For now, just note this. We'll talk about it next time we meet on Monday, and there'll be a couple things to do. Since you're already working on the individual project and you've already met a couple times as a team, I decided we'd take a little break from that, but beginning next Monday. And, you know, it looks like there's a long time between sprint 1 and 2, but Thanksgiving intervenes there. So, you know, and then 14 December, that's Wednesday of finals week. I don't know when our final exam is, but it doesn't really matter for that. The final incarnation of your product will be due the middle of finals week. Just you've seen it one time. We'll see it again later. Whoa, I'm really pushing it today. I only show I have 25 seconds left. And I got 200 more slides. Okay, now we won't do it. I'm kidding. We're really done. If you have some questions, I'll hang around, or feel free to email me. If I don't respond immediately, send it to my CUW email address, but I do check the CUI stuff. I check it. Folks, thanks so much for being here. Thanks for your rapt attention. Have a nice day. Have a happy rest of your week and weekend, and I will see you on Monday.